top of page 2. I know you know greater than or less than. Are you familiar with the symbol for greater than or less than and equal to? It's a less than symbol with a line underneath it. That means that it can be less than or equal to that number. No, it's kind of like it's showing you less than, and it's like has 1/2 of the equal sign. Okay, you'll see how it works when we do equations with this. And then the other side is, of course, greater than or equal to. You'll see how it works when we do the examples. All right. All right, do A, because it's just algebraic railroad tracks. Do it, solve for A the way you've been doing it, come up with an answer, and then I'll show you what you can do next. Okay, after you make the tracks, what do you have to do to both sides? Marcus, subtract 6. It's good practice, because you got to do this tomorrow's quiz anyway. Marcus, what cancels out? 6. Good. What's left on that side? 16 minus 6. What's the only value that y can be? Right, it has to be equal to 10. So it is true for only one number, 10. As basic as that seems, you'll see when we now deal with the inequality, there will be more than one number that will satisfy the inequality. Only difference now between A and B is instead of an equal sign in between the left side and the right side, you have an inequality, you have a greater than. You're still going to solve that like you would do railroad tracks. Even though they don't look like railroad tracks anymore, still make a line designating left side and right side. And go through the steps again. Subtract your 6 from both sides. And the 6's cancel again. And what do you get on the right side? Huh. Right. Right. So the numbers are the same. But now what you've solved for is all values that have to be greater than what? Say it. No, 10. Just think about it. Watch what happens when you substitute. If I put 10 in for y and I do 10 plus 6, what do you get on that side? Is 16 greater than 16? So it will not work for 10. So it's got to start at what number or higher? Luke, 11, assuming that we're doing integers, but you'll see, will it work for 10 and a half? It will, because we're not just including the rational numbers, or the integers. We can include rational numbers also. So if I say, let's just keep the integers right now, just so it's kind of clear in your head. Will 11 make this inequality? If I put 11 in for y, now I have 11 plus 6 is greater than 16, and I evaluate that side. What do you get on the left side? Say it. 17. Is that greater than 16? So that's true. Will it work for 12? 13. Obviously, everything higher than 10 or higher, or higher than 10. Can it be equal to 10? No. So I'm going to put, watch, I'm going to put 11, 12, 13, and if I put dot, 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 what does that mean? Does anybody know the symbol for infinity? I would be impressed if you know this. Tree? You want to do it? Yeah, go do it. Okay? That means it goes on for infinity. Watch out for that line. And you can draw it too. That's a good job right there. Yeah, that means it goes on forever. Alright? Now, just keep in mind, even though I put the integers 11, 12, and 13, it's also everything in between the whole numbers also. What about 11.8? 13.5? 27 and a half? 10.000001. You got it. So you have the right idea. Okay. Same numbers, different symbol. Solve for it using your railroad tracks like you've just done. Only differences you'll see is the symbol in between. I'm in the same spot as you are. I've got a little something in my throat going right now too. Yeah, something's going around. What's the only difference now between example B and example C? So it can now also be equal to 10 and then everything higher. So we can start at 10 and then 11 and then 12 and dot 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 to infinity. Trey's infinity was better than mine. He makes better infinity than I do. Okay? Will it work for 18? Does 18 make it true?
Yes.
28.
Yes.
10.1.
Yes.
10.
Yes.
Yes, now it does, because it can be equal to 9.999999. No good. Okay. All right, solve for G. It's an equal sign. Go for it. I'll call somebody up. It's good practice for tomorrow anyway.
Yeah.
Who would like to come up? Watch out for the line, Marcus. Who would like to come up and do 3G equals 15 using railroad tracks? Jack Troyce, come on up. Just watch out for the line here. While he's doing that, I just want to impress on you guys. Tomorrow, our goal for the quiz is 100. You'll be okay. Show your railroad track step by step and you'll be fine.
I knew it, but I just
Agreed?
Yeah.
Will any other number other than 5 make the statement true? Honestly, I don't want you to make this any more complicated than it needs to be. Once you solve for what that variable is, it's just like doing railroad tracks. The only difference is when you have inequalities, more than one number will make the inequality true. But you solve it exactly the same way as you do any railroad track question. Now I want to know, after I've done that, what numbers will make the inequality true. Marcus. Right. And anything in between, but we'll just keep the integers here. It does. It does. It's going to include all of your negative integers as well. When I say infinity, it can include now everything to infinity on what? The right side or the left side of the number line? Let me restate it. So it's everything from 4 on your number line. It's everything from 4 to where? The left or the right?
Right.
It's got to be lower than 4. On a number line, what's lower than 4? Or everything that's lower than 4 is to the left of the number line. 4, 3, 2, 1, and then 0, and all the negative integers and negative rational numbers. All right, you got one more you got to do. I'll show the example, or the exercise 1 we'll do together, and I think then you'll be fine. Well, we said we had to change this, right? This is B. Okay, so now what's the only difference between example B and example C? Colin. Yeah. What number? Right, so does it include 5 to make the statement true? It does. My infinity signs are getting better. Just saying. So 5 and what? Everything to the left of 5 on the number line, or everything to the right? Thank you, yes. All right, let's do exercise 1 together. And then you guys will be ready to go. All right, solve the inequality using railroad tracks. I'll call you up. All right, who wants to come up and solve it first? T-Rex coming up. Watch out for the line. Hold on, let me scroll up a little bit. Okay. Track it out. Do it. Did you guys get n greater than 13?
Yeah.
Okay. Can it be equal to 13? Not. All right, so now think on a number line starting at 13 are all the numbers that are going to make the statement true to the left of 13 or to the right? Ben, how many agree with Ben to the right? Okay, great. So then what you got to do, what if n is 15? Is the statement true or false?
True.
Is 15 greater than 13?
Yeah.
Of course. So either put yes or true, whatever you want to do. What if n is 8? No or false? 13 and a half. True. Again, either or. You can write true or yes. Neg 25. And that's what you guys are going to do. Okay? Now, I kind of want you doing, I have to make a decision with not only you guys, but period 3 as well. You need to take a break a little bit from working in groups. Okay? I think so. A little bit less for this class because you guys are pretty responsible. Having some difficulties with period 3. So, why don't you guys work on this? But I will give everybody privileges. Okay, but I want you to stop at page 6, because then after page 6 is really our lesson for after the break, and that's how to graph it. Okay, which is not difficult either, but I want to devote a period to that as well. So when you're done with page 6, come up, check it. It's hanging up here, and then I'm going to let you start your in-class review.